Hello Math Analysis students! Today in this video we are going to be talking some more about ellipses. Now remember in our previous video in class we learned what an ellipse is. We learned how to graph an ellipse when we know the center and A and B values, and we learned how to write the equation of ellipse when we were given a graph. We also talked about how to write something in standard form. This video we are going to talk about the foci of an ellipse and also how to get the equation when we are given different pieces. Okay, so remember that an ellipse is the set of all points where the distance from the foci is constant. So what are foci? So one important thing that I want to note up here, just in general, is that the word foci is the plural of focus. Focus is singular. Foci is plural. So foci is more than one focus point. And the focus points, or foci, are points that lie on the major axis of an ellipse. And the significance of the foci is that any point that is on the ellipse, if you were to measure the distance from that point to each of the foci, the sum of the distance from one foci to the other foci would be constant. That means no matter what point on the ellipse you measured from. It might be at a point that's up here, it might be at a point that's way down here, or over there. Any of those points, if you measure the distance to the foci, that will be a constant value. Okay. So the foci, remember, they lie on the major axis. That's very important for us. And we have a way to find the foci. For a horizontal ellipse, then our foci are the coordinates h plus c, k, and h minus c, k. For a vertical ellipse, we have h, k plus c, and h, k minus c. Well, you may be wondering, where did c come from? We already have an a value and a b value, and to find c value, we use this relationship right here. C squared equals a squared minus b squared. You may be thinking that looks familiar because it looks an awful lot like the Pythagorean theorem, but Pythagorean theorem has a plus in it, so don't go using a plus for this one. Now on our graphs, what does it represent? Let's take a look back up here at this problem for a minute. On this particular graph right here, then our a value is the distance from our center to our endpoint of our major axis, the major vertices, and our b value is the distance from the center to the endpoint of a minor axis, and then the c value lies somewhere along this major axis. In this one it's approximately right here. And a is always larger than the other values. So c squared equals a squared plus b squared. I think it's super helpful just to remember what those values mean. A is the distance from the center to the endpoint of the major axis. B is the distance from the center to the endpoint of the minor axis. And c is the distance from the center to a focus point. All right, so let's practice finding. In our last class, we had this ellipse, and we had the equation for us in standard form, and we found the center, we found our a and our b values, and we graphed it, and now we're going to work on finding the foci. Since this is a horizontal ellipse, then our foci are at the points h plus c, k, and h minus c. Okay, so we're going to find these, and then we're going to talk about what that means on the graph also. We have an a value of 5, and a b value of 3, so we need to find c. I'm going to come over here. C squared equals a squared minus b squared. Since our a squared value is 25 and our b squared is 9, that gives us c squared equals 16. So our c value is 4. So to find the foci, h plus c, okay, and h minus c, okay, because we're moving the same amount horizontally left and right from our center. So if our center is 3, 0, then 3 plus 4 would be 7, 0, and 3 minus 4 would be negative 1. 0. And graphically, if we were to look at this, since c means 4, this is the distance from the center to the focus point. So from that center, it's going left 4 units right here and right 4 units here. Okay. Another example, last class, we also worked with this ellipse. We found the center to be 1, -2. Our A value is 4, our B value is 2. This one is a vertical major axis. So let's find the foci. Since our ellipse is vertical this time, our foci are at slightly different values, h, k plus c, and h, k minus c. Now this is similar to what we just had last time, but on the previous one it was a horizontal major axis, so our x-coordinate is what was being adjusted. The focus was moving left and right of our center coordinate, moving left and right of the x value of our center coordinate. Since this one is a vertical major axis, then our foci are going to be moving up and down from the y value of our coordinates from the center. Okay, let's find our relationship over here. C squared equals a squared minus b squared. See, a squared was 16, b squared was 4. So c squared equals 12. So what does that mean for us? C is the square root of 12. So when we're writing our coordinates, h, k plus c, and h, k minus c. Now remember here that even though this one was written differently, we had our y first, our h value was 1, and our k value was -2. So remember that when we're writing our focus points, our h value is 1, and our k -2 plus the square root of 12. What we're just going to write that as -2 plus the square root of 12. And the other one is going to be 1 and -2 minus the square root of 12. Now, if you prefer, you could write this as 1, -2 plus or minus the square root of 12. What does that mean graphically? It means that our focus points are square root of 12 units away from our center. So to graph these, we would need to know the approximate decimal value. And the square root of 12 is somewhere around 3.5, 3.5, excuse me. So we would be coming out about 3.5 units. Now, in this case, our foci are pretty close to our endpoints of our major axis. This is what that c value represents, the distance from the center to the focus point. Okay. We also had this one where we had the equation, and we had the graph. We found our equation. Let's find our foci right here. Since this one is horizontal, then our foci, our focus points, will be h plus c, k, and h minus c. Okay. Excuse me, that should say h minus c, comma, k, not another minus. Oh goodness, I just messed up on that part. Let me fix this whole thing over. Sorry about that. That should say h minus c, comma, k. There we go. Okay, so to find those coordinates, let's use our c squared equals a squared minus b squared. And we know that our a squared is 25. Our b squared is 4. So c squared equals 21. That means c equals the square root of 21. So our coordinates here would be 0 plus the square root of 21. We don't have to write the 0. We can just write square root of 21. But we do need to write that 0 for our other coordinate. Square root of 21, 0. And h0 minus the square root of 21, 0. Okay. Or we could write plus or minus square root of 21, 0. Alright, for this one, we have a vertical major axis. So this time, our focus coordinates, remember that we're going to be moving up and down from our center point. Our x is not going to be changing, but we'll have h, k plus c, and h, k minus c. So let's calculate c. C squared equals a squared minus b squared. This one should be looking kind of familiar to us because these are the same numbers we had in our last one. 25 minus 4, c squared equals 21. So c is the square root of 21. So our coordinates for our foci here will be 3 and 2 plus the square root of 21. That's moving up. And c 2 minus the square root of 21. That's when we move down from our center value. Okay. We talked a little bit about writing things in standard form, and we'll practice that during class. So I'm not going to do any of these right here. But remember that we complete the square for x and y, and we divide by the constant. And our last three problems right here are going to be about writing the equation of the ellipse when we're given different pieces of information. So in this one, we don't have any equation, but we know that our major axis is horizontal with length 8, our minor axis is length 4, and our center is 0, 0. So I've included a graph here. You can certainly do this without a graph, but graphs make it graphs are very helpful for these. All right, our center point is at 0, 0. And if our major axis is horizontal, we're going left and right, if the length is 8, that means the whole thing is 8, then that seems like our a value is going to be 4. So we'll be moving left and right 4 from our center point. And our minor axis has length 4, which tells us that our b value is 2. Up 2 and down 2 from center. And then to write the equation, well, since our center is 0, 0, x squared over something plus y squared over something equals 1. Since it's horizontal, our a squared goes underneath our x term, and our b squared goes underneath our y term. And there we go, x squared over 16 plus y squared over 4 equals 1. This example, we're given endpoints of the major vertices and endpoints of the minor vertices. So we could find our center is going to be the midpoint of those. I'm going to go ahead and graph it. Again, you can certainly do this without graphing, but this tends to make it a little bit nicer. Okay, so if we graph 6, 5, that is 6, 5 over here, and 6, negative 11, that goes off of our graph. We could extend it if we wanted to. 6, negative 11, or if we have something that's really difficult, remember that we could always use that midpoint formula, which we talked about that with our circles. We can certainly find the midpoint formula without having to graph this. I'm going to go ahead and put in my minor vertices also. My minor vertices are at 11, negative 3. Once again, this is going off of my grid right here. 11, negative 3, and 1, negative 3. So when we have both of them, it hopefully makes it a lot easier for us to see where we end up with our center point. So if we could calculate, or if we're drawing, then we end up with our center right here at 6, negative 3. So since our center is 6, negative 3, it is a vertical ellipse. Our a value is from the center to the endpoints of the major axis, that is 8, and our b value from the center to the endpoints of the minor axis, that is 5. So when we go to write our equation, we would have x minus 6 squared over some number, and y plus 3 squared over equals 1. Don't forget that. And since it's vertical, our bigger number needs to be underneath our y term, and our smaller is underneath our x term. So this is a 25 under x, and a 64 is under our y value there. And again, don't forget the equals 1. And our last problem here, write the equation of the ellipse if we know that the foci are at negative 5, 0, and 5, 0, and the major vertices at negative 8, 0, and 8, 0. Okay, this time we don't know anything about minor axis, but that's okay. If we've got two pieces of information, we can figure out the others. Between A, B, and C, as long as we know two of them, we can figure out the other. So it's going to be helpful to graph this. Our foci are at negative 5, 0 and 5, 0. Okay, looks like we're going to be able to tell where the center is. Our major vertices are at negative 8, 0 and 8, 0. So yeah, this confirms that our center right here is at 0, 0. Okay. The center is 0, 0. Our A value right here is 8. That's the distance from the center to the endpoint of the major axis. And our C value right here, that is 5. That is the distance from the center to the focus. So now we can calculate our B value to get our equation. So C squared equals A squared minus B squared. So our C squared is 25. Our A squared is 64 minus B squared. And when we solve this equation, we get that B squared equals 39. We can go on if we want and get that B is the square root of 39. We don't actually need that because in our equation we just need to write B squared. But since we have a horizontal right here, then our bigger number is going to go underneath our x. Our center is in fact 0, 0. So x squared over what plus y squared over what equals 1. Distance from our center to our endpoint of our major axis is 8. A is 8. A squared is 64. And we concluded over here that our B squared is 39. So we can write the equation when we know different pieces. We could also graph this if we needed to. For the square root of 39, we would need to get a decimal value, 6 point something. We could certainly graph that. As long as we know any two pieces between A, B, and C, we can always find the other one, though, because of that relationship, C squared equals A squared minus B squared. Okay. If you have questions, ask. And next class, we are going to be talking about a new type of conic section called a hyperbola. Bye.